1 gigabyte. 1 gigabyte of RAM is a museum piece. You'd only find it today in old laptops buried in closets or in tiny embedded devices like routers. Back in 2007, you could open a Word doc, surf a very basic internet, maybe launch a simple game. That was the ceiling. Today, Windows 10 idles at nearly 1 gigabyte all by itself. Before you've opened a single thing, Chrome with 2 tabs will bring a 1 gigabyte machine to its knees within minutes. There is no use case for 1 gigabyte on a real computer in 2027. None. Not gaming, not browsing, not basic productivity, nothing. Moving on fast. 4 gigabytes. 4 gigabytes is technically alive. That's the nicest thing I can say about it. From around 2012 to 2018, 4 gigabytes was considered totally fine. Browse, watch YouTube, send emails. It worked. And then browsers happen. Chrome is a RAM consumption machine. Every tab you open costs memory. 5 tabs, Spotify in the background, a PDF open, zoom, your computer starts sweating. When RAM fills up, Windows quietly starts moving data to your hard drive instead. That process is called paging. And when paging kicks in, performance collapses. Not slows down, collapses. You'll sit there watching your cursor spin, wondering what went wrong. Nothing went wrong. You just ran out of disk space. And your hard drive, no matter how fast, is nowhere near as quick as RAM. Here's the thing they don't put in the ads. 4 gigabytes meets the minimum requirement for Windows 11. Meets it. Barely. That's not a recommendation. That's a warning. If budget is the only option, 4 gigabytes survives light use. Everyone else, push harder. 8 gigabytes. 8 gigabytes is where computers start cooperating with you instead of fighting you. 10 plus browser tabs open? Fine. Office apps running? No problem. Spotify, Discord, a YouTube video in the background. 8 gigabytes handles all of it without drama. For everyday use, it's the sweet spot. Gaming works well at 8 gigabytes for most titles. Older games, indie games, mid-range titles, totally comfortable. But some newer open-world games are starting to push against that ceiling. You might get occasional stutters in the heaviest releases. Now here's where something interesting happens, and most people don't know this. Apple's M-series chips, M1, M2, M3, use what's called unified memory architecture. It means the CPU and GPU share the same RAM pool, and it's absurdly efficient. 8 gigabytes on an M2 MacBook is not the same thing as 8 gigabytes on a Windows laptop. Apple genuinely squeezes more out of it. It's one of the few times where 8 gigabytes in 2027 still makes a real argument for itself. On Windows, you're cutting it closer than you think. For students, office workers, casual gamers, 8 gigabytes is your number. 16 gigabytes. 16 gigabytes is where you stop thinking about RAM entirely. And that's exactly the point. Developers running local servers while jumping between apps and docs, 16 gigabytes handles it without blinking. Gamers love it because most titles are now optimized for it. Smoother performance, faster load times, less stuttering in open-world games that devour memory. Even if a game only officially needs 8 gigabytes, with 16 gigabytes, Windows isn't competing with your game for resources. That headroom matters more than most people realize. 1080p video editing? Very comfortable. Graphic design? Totally at home. Light 3D work? Handles it. Here's the honest recommendation most tech channels won't give you. If you're buying a laptop or desktop today, and you want it to stay relevant for the next 5 years, 16 gigabytes is the move. Not because it's impressive, because apps keep getting heavier and 16 gigabytes buys you time. 32 gigabytes. 32 gigabytes is where things get serious. 4K video editing in Premiere Pro, DaVinci Resolve, Final Cut Pro, these apps are RAM monsters. The more you have, the smoother the preview playback, the faster the renders. At 32 gigabytes, the progress bar stops being your enemy. Developers spinning up multiple virtual machines or Docker containers? 32 gigabytes is practically a requirement. Architects and engineers with CAD software Or large simulations? Same story. Gamers who stream, meaning the machine is gaming and encoding simultaneously, 32 gigabytes keeps both tasks happy without either one suffering. For a regular user, this is a sports car parked in a supermarket car park. You're paying for capability you'll never use. But for creators, and this is where it gets counterintuitive, 32 gigabytes isn't a luxury. It's what separates a smooth workflow from a frustrating one. There's a reason professionals buy it without hesitation. Once you've worked at 32 gigabytes, going back feels like working with one hand tied behind your back. 64 gigabytes. 64 gigabytes is a tool, not a consumer product, a tool. High-end 3D artists in Cinema 4D or Blender with massive scene files. Professional editors cutting 8K footage with complex color grades. Data scientists keeping entire datasets in memory so they never have to read from disk. Audio engineers running hundreds of virtual instrument plugins in a single session. People running 3 or 4 virtual machines simultaneously with real workloads. Each VM needs breathing room. 64 gigabytes gives it. For a gaming PC, the game won't use it. Windows won't use it. It will sit there, completely idle, costing you money. The rule with 64 gigabytes is simple. You only need it if 32 gigabytes has already failed you. And you know it, because your work made it. 128 gigabytes. Let's be honest about what this is. Genomics research, climate modeling, large-scale physics simulations, datasets so enormous they need to live entirely in RAM to be processed at any workable speed. This is university research lab territory, government computing, the kind of work that normally runs on server clusters, and someone has decided they need it local. Machine learning engineers fine-tuning large models locally, not on cloud services, can push into this range. Massive matrix operations, keeping enormous data sets in memory for fast access during training runs. High-end post-production studios where multiple editors share workstations and hundreds of gigabytes of media need to be cached at once. Here's the thing. If you're watching this video and you're genuinely wondering whether you need 128 gigabytes, you don't. The people who need 128 gigabytes aren't wondering. Their work has already told them, loudly, repeatedly, in failed renders and crashed processes and hours of waiting. They didn't Google it. They lived it. 128 gigabytes is impressive. It is also completely irrelevant to 99.9% of the people alive.